Good morning, happy Wednesday. We are working on Module 6, Lesson 17 today. There is a reason that I chose this as my background. Why do you think, after you have watched this lesson, tell me if you can think of why I chose this to be my background. Now, you are going to have the document pulled up, and on Google Classroom, you're going to have paper and pencil. You're going to complete the Zern, and then once you finish all of that, meet us in office hours. Today's lesson is really cool. So when you come in and watch this video, I will give you the code word throughout this video, so keep it going, and then trying to figure out why did I do it like this. All right, see you all soon. So we are going to talk about line of symmetry today. You probably have heard something is symmetrical, oh, there's symmetry between something. Think about what you think that means. Now, if we're looking down at my paper, I have some graph paper here. I'm gonna draw right here and just make a straight line. This is my line of symmetry. Okay, so now I'm gonna make a point right here. I'm gonna call this point A, okay? Now, if I were to fold my paper along my point of symmetry here, my line of symmetry. Okay, so I'm folding it on my line of symmetry. You're gonna see here, oops, I used 2 sheets of paper. You are going to see here, let me make it a little bit darker. So here's my point A, I'm folding it over. Okay, it created, let me lift it back up so you can see. So I have my line of symmetry down the middle. That's where I folded it. I have point A right here, and then you can see that little mark there. I'm gonna call that point B. Now, what you should notice about it is when I look at A is how many away from my line of symmetry? A is 4 units away from my line of symmetry. 1, 2, 3, 4. And when I flipped it, B is also 4 units away from my line of symmetry. Now, I'm gonna take my straight edge and I'm gonna connect lines A and B. So let me show you what I'm doing. I have A and B across my line of symmetry, connecting A and B. Now, looking what I have, my line of symmetry and my connection of A and B, they are perpendicular to each other. So as you look at these, we are measuring the same distance on the opposite side. So this is the same distance from B to our line of symmetry and A to our line of symmetry. They are equidistant, right? Equal, distant. They're the same distance from that line of symmetry. So we say that those points are symmetric. They are the same, but on other sides there. When it's symmetry, it flips over and it's the same thing. How did my face at the beginning of this video represent that? All right, so we've just talked a little bit about what the line of symmetry is, right? It's equal on both sides. So now that we're looking at the lesson, it wants us to create a figure that's symmetric about AD. So that means that this, our green line right here, this is that line of symmetry. So we need it to be symmetric or equal, identical to the other side. So imagine that green, right? Imagine you're on a sheet of paper and this green line is telling you where you're going to fold the paper. Where are all the marks going to sit? Well, when I look at it, if I had a ruler, I would take out my ruler and I would measure right here and say, okay, I found that distance, so it's going to go right here. I'm going to put my point here. I'm going to maybe put my point there, okay? Then I'm going to say, okay, and now CD right here went like that, so it's going to go like this, and then BC are going to connect, and those 2 points are there and there. All right, now, again, it's a little wobbly because of my pen, but again, you're imagining that you're taking these 2 sides, lifting them up, folding them, and that when they touch those black lines, your shape are touching on the exact same lines. So let's look at number 2. You want to do the same thing. Now, here's our line of symmetry. Let me make that a little bit darker. Okay, there's our line of symmetry. Again, imagine it's straight. All right, you are not going to just say it goes across like this. It does not do this. Why not? Well, that's not how you would actually flip it. This line of symmetry is not directly up and down. It's a little bit diagonal. So if you were to flip it and imagine that it's paper, right? You're closing a paper. It's actually going, let me keep this straight. It's actually going a little bit up like this. Then it would come down, right? That's right here. Now I'm looking for this line, so it went in and then this comes back out, and it comes back out. Those points should touch. Now, if you imagine as it were a piece of paper and it folded over, these would overlap. So let's look at number 3. Plot 3 non-collinear points, D, E, and F. Non-collinear means they are not all on the same line. They're not just in a row next to each other. So let's see, I'm going to put D here. I'll put E here. And I'm going to put F here. No. Yeah, that's fine. Okay. Draw DE, okay, DE, EF, great, and DF. So let me move my E out of the way here. Let me mark this was E, okay, and DF, so connecting DF. Okay, so it made a little triangle there. Plot point G and draw the remaining sides such so that it is symmetrical about DF. Okay, so it's saying DF, which is right here. This is what it wants it to be symmetric. So this is our line of symmetry because it said it right here. It's symmetric about. That tells us where. Okay, so plot point G and draw the remaining sides so that DEFG is symmetric. Okay, so then G is going to need to be this E here. So it's about 1 dash there, so 1 dash here, okay. So I'm going to say here is point G, and if it wants it to be symmetric, we need to connect. Now, if you were to fold these over that line of symmetry, they would be equal. Make sure that you have all of your points labeled, and make your line of symmetry a little bit darker, maybe a little bit bolder, just so it's easier to see. Moving on to the next page. Stu says the quadrilateral HIJK is symmetric. Let's look. HIJK. Okay. Is symmetric about HJ. So that's telling me my line of symmetry. HJ. Right? The H is telling us this point, the J is telling us this point. And it says the reason is because IL equals LK. Let's see. IL is here, and it equals LK. That looks about right. Use your tools to determine Stu's mistake. Okay. So he's saying it's equal because IL equals LK. But is that true? Well, if we were to take our protractor right now, and we were to measure all of these angles, we would get that right here is 30 degrees. And we would get that right here is 20 degrees. We would measure here is 30 degrees and here is 51 degrees. So what do you notice? I notice that all of those angles are not the same. So our answer here is that even though, this is what you're writing, IL equals LK. So yes, that's true. The adjacent angles, right? The angles next to each other, the adjacent angles from the line of symmetry which we know is HJ, they need to be the same size, should be the same size. So I'm going to show you exactly where I'm talking about. Right, let me use a new color to make it clear. Right here, the angles next to each other should be the same. If we are going to say that they are exactly the same line, they need to be the same. In order for this to be symmetrical, this line needs to be a little closer in. It needs to be at 30 degrees, not at that 51 degrees. Then it would be the same. Angle LJK should be equal to LJI. I'm going to show you that again. LJK, let me erase all of this to show you. Angle LJK should be equal to LJI. Angle LJK should be equal to angle LJI. They should all be equal to each other. All right, now you are moving into your exit ticket. Follow these directions and you are going to show us your work when you come to office hours. Again, make sure they are symmetrical over the line of symmetry, and I will see you in office hours. The code word is brownies. The code word today is brownies.